This is problem number 5 from section 5.3. In this problem it says, a particular type of bacteria is found to be capable of doubling in number about every 48.6 minutes. The number n of bacteria present after t minutes could be modeled by n of t equals no e to the 0.014 t. Suppose that no is 400,000 is the initial number of bacteria per milliliter. Suppose that n sub 0 is 400,000 is the initial number of bacteria per milliliter. Complete parts A and B. So I want you to approximate the number of bacteria per milliliter after 3 hours. So let's start with part A. Let's label what we know n of t to be. So n of t is the number n of bacteria present after t minutes. So n of t is the number of bacteria and t is the time in minutes. All right, now that we have that defined, let's use this formula. So if they say they want to know the number of bacteria after 3 hours, first thing we need to do is write the formula out. So n of t equals, they say NO is 400,000, so we're going to use 400,000 in the formula. And this is e to the 0.014 t. Now we're going to plug in 3 hours. So 3 hours, how many minutes is that? Well, we can take 3 hours times 60, and that equals 180 minutes. So we're going to go ahead and say that n of t equals 400,000 e to the 0.014 times 180, which equals, let's plug all that in the calculator. So 400,000 e to the 0.014 times 180. And that's going to be 4,971,000, and I think they want us to round it to the nearest thousand. So 4,971,000 bacteria after 3 hours. Okay, part B. Estimate graphically the elapsed time when there will be 11 million bacteria per milliliter. So if they want to estimate that graphically, we're going to go ahead and use the calculator to graph this. We're going to type in this function. So let's go y equals, and we're going to say 400,000 e, oh, wrong button, e to the 0.014 t, or x for s. Now I want to make sure my window's set properly. So they're talking 11 million. So we want to go to our x values. Let's see. Our x values probably need to go, I'm going to delete this and say 0 to 1,000 minutes. I think that should be enough. And then we're going to go up by, let's just go up by 100. And then let's go, y min is going to be 0. Or actually, if we want 11 million, maybe we could just say our y min is 10 million, and our y max is 12. And we're going to go up by Let's go up by 500,000. See what that looks like. Now let's see if we can find 11 million. So we're right at 11 million right here. And that would be an X value of 242. So that would mean 242 minutes. To get 11 million bacteria. And those are the solutions.